All right, in 6.2, we're going to look at attributes of absolute value functions. Now, when you say attributes, that's another fancy way of saying characteristics. So we're going to continue that idea of transformations. We're just going to look at different ways we can describe absolute value functions. So notice the instructions. It says graph each absolute value function, graph it first, and then analyze the maximum and the minimum on the given interval. All right, so there's two parts to this. We got to graph it and analyze. So let's first graph this, and I'll show you what I mean by analyze maximum minimum on the given interval. Now, one thing I would point out is that when it says interval, you need to think about this. When it says given interval, they're going to tell you the x values to look at. All right, looking at the x values, and I'll demonstrate that for you here in a moment. All right, moving back to number 1. Look at this. F of x equals 2 times the absolute value of x plus 4 minus 2. And then this is the interval I'm going to look at in a moment. Let's graph it first. So remember, our origin starts at 0, 0. Well, this is moving us opposite logic, so it's going to move us left 4, 1, 2, 3, 4, and down 2, 1, 2. So there's my new vertex. Now my slope, notice, is a 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Same thing here. So I'm going to have a really skinny looking V, right? V for absolute value. All right, so I've graphed it. Now it's asking me to evaluate the interval where x between x is -6 and -3. So I'm going to look at my graph. 1, 2, 3, 4, 5, 6. So I'm going to look from here to -3. All right, and I want to know what is the maximum and the minimum value. Now, so when we talk max and mins, we are talking about y values. All right, what is the maximum y value on this little sliver of information? So the highest y value is going to be a 2. Maybe I need to highlight to show you. Within just this interval, I just look at this one interval. The highest it gets right here is 2. The lowest it gets is down here at -2. So I can write my maximum at +2, my minimum at -2. So these are the y values, okay? Let's try number 2. Let's again start with graphing. So at -x minus absolute value of x minus 2 plus 3 over the interval 1 to 5. Now let's start here. My origin originated here. It's going to go down 2, up 3. I'm sorry, not down 2. That should go right 2, up 3. 1, 2, 3. And my new origin is here. Now, notice the negative in the front. If you remember, that negative means it's going to point down, but it's still a slope of 1. So down 1 over 1, down 1 over 1. All right, so then I use my straight edge, draw my absolute value. All right, now I'm going to look at just the interval from x is 1 to 5. So from here to right here. I'm just looking at this little piece right there. And I'm going to figure out what is the highest y value. That's my max right there. And my lowest y value. Well, that's right here. Okay, so then my maximum then is a 3. My minimum then is at 0. All right, that's the first kind of problem you're going to be working today. Now the next part says state the domain and range in interval notation, then state the intercepts and symmetry of the graph. All right, so let's kind of review for a moment. When we did domain and range in interval notation, if you remember this, domain, if we said all real numbers, it looked like -infinity to +infinity. Okay, the interval notation looks like almost like an ordered pair, right? An xy coordinate. When we did intercepts, remember x-intercept and y-intercept. So Your x-intercept is where the y value is 0 and where it crosses the x-axis. The y-intercept is where the x value is 0 and it crosses the y-axis. Okay, so it's an ordered pair in my answer. So instead of graphing new things, we're just going to use that graph we started with in number 1 for number 3. So using the graph from problem 1, we're going to find the domain and we're going to write it in interval notation. So remember, domain is when you collapse it down to the x-axis, what x values would be used. Well, all the x values would be used because of those arrows. They're pointing left and right. So my domain would go from negative infinity to positive infinity. My range, remember we always go from low to high, so the lowest y value is going to be a -2, and then it goes up to positive infinity. We put a bracket on the -2 because it exists there, and a parenthesis on the infinity because that's what it is. Now, the x-intercepts, notice that if I look at my graph, it crosses the x-axis in 2 locations, right? So that means I'm going to have 2 x-intercepts. So I need to list those as points, ordered pairs. So I'm going to say -3, 0, and -5, 0. Y-intercept, where is it crossing the y-axis? Well, that's crossing up here. Oh, right here, sorry. And what value is that? 1, 2, 3, 4, 5. At 0, 5, there's my y-intercept. Now, axis of symmetry is really not that hard to figure out. Is the line that goes through the vertex. So you would locate the vertex and then draw, usually it's a vertical line like this that goes through that point. And the vertical line, if you recall, is going to, when you write the equation, it's going to be an x equals line if it's vertical. And in this case, it's going to go through 1 to -4. It's going to go through x equals -4. So it's a vertical line that goes through the vertex. All right, let's do the same thing with number 4 using graph number 2 here. So domain. Okay, visualize collapsing this down to the x-axis, and which x values will it use? Well, interval notation would look like this, negative infinity to positive infinity, because all x values are being used because of the arrows pointing left and right. Now the range, notice the range goes from bottom to top, least to greatest. It's going from negative infinity up to a positive 3, but it stops there. So it would go from negative infinity to positive 3, least to greatest, parentheses around infinities. I would put a bracket on the 3 because it is going through that point. Now the x-intercepts, notice these x-intercepts right here. We want those values to be listed as ordered pairs. So I would have it at -1, 0, and I'd have an x-intercept at 5, 0. Y-intercept is where is it crossing the y-axis? Well, it's crossing right here, where x is 0, y is 1. And then axis of symmetry, remember it's the vertical line going through the vertex. So it's going right here where x is 2. So it's a line that x equals 2. All right, let's move on to the third kind of question you're going to see today. Graph an equation, write an equation to represent the graph shown. So the first thing I want to do is look at where's my vertex now. Remember, it used to be here. So let's look at what happened here. The x value has gone 1, 2, 3 to the left. So my vertex is now -3, 0. So vertex is -3, 0. That's going to be handy for me when I write my equation. Look at my slope. It goes up 1 over 1, up 1 over 1. So that is not changing. I don't have a vertical stretch or shrink. So I can write my equation. Absolute value of x. So remember, it's going to be opposite logic. So if this is -3, this should be a +3. And it's not moving up or down, so this is the extent of my equation. That's it. All right, so let's look at number 6. Again, start with my vertex. Where is it now? It's not at 0, 0 anymore. It's at 1, 2, 3, 4, 5. And it went down 1, -1. And then let's check slope. Does it go up 1 over 1, up 1 over 1? It does indeed. So there's no vertical stretching or shrinking. So it's going to be x, and it's minus what I have for 5, so it's against logic, remember? And then I just bring the negative 1 straight down. Now just remember for a moment, when we did point slope, it looked like this, right? Way back in the day. If I move that y1 value over here on the right, I want you to see what's happening here. The slope is on the outside. The x minus x1 is what we're putting in the absolute value bars. And what you need to catch here is that this x1 and this y1 are from my vertex. Okay, and notice it's negative, it's opposite logic in the parentheses, and it's exactly what the y1 value is over here in the back end. So it's this point slope model that we use on each of these. Let's look at number 7. Find our vertex. It's going right 1, and it's going to go 1, 2, 3, 4, up 4. Now, let's look at slope. It's definitely not 1 anymore. What's happening to my slope? Let's see, I go down 1, 2, over 1, 1, 2, over 1. So it's down 2. So since it's going down, that makes it negative, and it's going down 2. So as I write my equation, that slope goes on the outside. X minus, it's going to be minus 1 against logic, remember? Plus 4. The 4 stays the same. Last one, look at number 8. Vertex, it's moved 1, 2, 3, 1, 2, 3. So it's 3, 0. Obviously the slope has changed. It does not look normal. So let's see what it is. It's up 1 over 2. 1 over 2. So, write my equation. I'm going to put my slope on the outside. X, not plus 3, it's opposite logic, minus 3. And there's no y vertical shifting going on. So this is my answer. I hope this video makes sense to you and has helped you. And let's see what questions you have when we get back to class tomorrow.